or rate of change of a function. You might be wondering, what is actually applied minimum and maximum problem? Well, it is the process of finding maximum or minimum values is called optimization. There are many application problems in calculus involve function to find maximum or minimum values. In real life, applied minimum and maximum problems is usually used to maximize the profit in a company or minimize the cost to make a particular object. However, in calculus, to calculate the highest and lowest point of the graph or to know its turning point. Why do we have to learn these applied minimum and maximum problems? Well, first and foremost, it is to increase understanding about application of differentiations. Other than that, it is to understand applied maximum and minimum problems. And lastly, it is to able solve the problem by using the suitable formula.
Problem statements. 6. A cylindrical can of radius r cm and height h cm is to hold 100 by cm cube of orange juice. The cost of material used for the top and bottom of the can is 4 cents per square centimeter, and the cost of material used for the curved side is 3 cents per square centimeter. Problem statement 1. Show that the total cost in cents for constructing a can is C equals to 8 pi r square plus 600 pi over r. Problem statement 2. Find the dimension of the can such that the total cost of constructing the can is minimum. Problem 1. Show that the total cost in cents for constructing a can is C equals to 8 pi r square plus 600 pi over r. In order to solve this question, we will use a formula of cylinder volume, which is V equals to pi r square h. The next step, we will use a cylinder surface area formula, which is A equals to 2 pi r square plus 2 pi r h. And the next step, we will multiply with the cost given, which is 4 cents, the cost material for the top and the bottom of the cylinder, and 3 cents, which is the cost material for the curved side of the cylinder. Solution for problem statement 1. First step, we will use the formula of the cylinder volume, which is V equals to pi r square h. And we will equal to it with 100 pi, which is the volume given in the question. So, we will get the h value is 100 pi over pi r squared. The second step, we will use the formula of area for the cylinder, which is 2 pi r squared plus 2 pi r h. The first line, it shows that 2 pi r h, which is the h value, was substituted with the 100 pi over pi r squared, which is the h value that obtained in the first step. And the next line, 2 pi r squared will be multiplied by 4, which is the cost material for the top and the bottom of the cylinder, plus 2 pi r multiplied by 100 pi over pi r squared multiplied by 3, which is the cost material of the curved side of the cylinder. The next line, we will get 8 pi r squared plus 600 pi squared r over pi r squared. The 8 pi r squared will obtain from the multiplication of 4 and 2 pi r squared, and 600 pi squared r over pi r squared will obtain by 2 pi r multiplied by 100 pi over pi r squared multiplied by 3. And the next line, we will get 8 pi r squared plus 600 pi r that we obtain from the cancellation method, which is the pi square over pi will cancel and we'll get pi, and r over r square will cancel and we get r, so we will get 600 pi over r. So it shows that C equals to 8 pi r square plus 600 pi over r.
To solve this problem, we need to find the derivative dA over dr for A equal to 8 pi r to the power of 2 plus 600 pi r to the power of negative 1. Next, let the derivative dA over dr equal to 0, and we have to find the second derivative. We show how to solve the problem for two domain. To solve this problem, we need to find the derivative dA over dr for A equal to 8 pi r to the power of 2 plus 600 pi r to the power of negative 1. We have to differentiate 8 pi r to the power of 2 plus 600 pi r to the power of negative 1. and we get 16 pi r minus 600 pi r to the power of negative 2. Since r has a negative power, so we need to bring it down to be 16 pi r minus 600 pi over r to the power of 2. Next, let the derivative dA over dr equal to 0, so we can find the value of r. 16 pi r minus 600 pi over r to the power of 2 equal to 0. Next, we move the negative 600 pi over r to the power of 2 to the other side, so it will be 16 pi r equal to 600 pi over r to the power of 2. Then, we multiply r to the power of 2 with 16 pi r, so we get 16 pi r to the power of 3 equal to 600 pi. We move 16 pi to the other side, so that r will be a formula thing. We get r to the power of 3 equal to 600 pi over 16 pi. Then, we move power of 3 to the other side, make r equal to the square root of 600 pi over 16 pi, and we get the value of r, which is r equal to 3.35. Then we need to find second derivative d to the power of 2a over dr to the power of 2 for 16 pi r minus 600 pi r to the power of negative 2, and we get 16 pi plus 102,000 pi r to the power of negative 3. Same as before, since r has a negative power, so we need to bring it down to be 16 pi plus 1200 pi over r to the power of 3. Next, insert the value of r equal to 3.35 into second derivative to find out the minimum or maximum point. If the second derivative has a positive value, it is the minimum point. If the second derivative has a negative value, it is the maximum point. D to the power of 2a over dr to the power of 2 equal to 16 pi plus 1200 pi over 3.35 to the power of 3, and we get 150.54. Since it is a positive value, so it is minimum. Next, we have to find the value of h using the equation we get from problem 1 Roman, which is h equal to 100 pi over pi r to the power of 2. Insert the value of r equal to 3.35 into this equation, so we get h equal to 8.91.
Acknowledgement. We would like to express our special gratitude to our beloved lecturer, Madam Nova, who gave us this golden opportunity to do this project on the topic of apply maximum and minimum problems. We also sincerely thank our lecturer of Calculus 1, Madam Nova, for all the guidance and willingness to help us complete this assignment. The assignment is impossible to be done without the help of Madam Nova and the amazing cooperation and the effort of our group members.
Next, conclusion. To conclude, there are various applications we involve the maximum and minimum value when a certain quantity is need to be solved. Next, apply maximum and minimum problem can help you to deal with our life problem. It can relate to our life such as a business, support, and so on. Many of these can be solved using the differential calculus method. Thus, everything we can see in this world is based on the concept of maximum and minimum to provide a solution to the related problem as we always compute the maximum and minimum value of a some data set. We need to appreciate and apply the things that we have learned because it will provide the benefit in your future.